The technology is punishing me. And the YouTube video, right after it will be there on YouTube. It's not gonna go away now.
Okay, sir.
Yeah, but I think I'm sending you the link now.
Okay.
Tell me if it's. Tell me if it's. Tell me if it's. Tell me if it's. You got the link. So
I do. So can you send it on Teams?
the link.
Yes.
Okay, let me try that because I'm using the okay, but I think I can do that. Let's see if it works. You have it.
I am getting it now, sir. It's not connecting.
It's not connecting. Let me try to forward it this side. Can you forward it on Teams from your WhatsApp, the one I sent to your WhatsApp?
Can I? Yeah, I can try. Let me go try. I sent it.
Yeah. Then follow that link on your phone. I'm sure there will be a video there.
Did you get it?
You got it.
So there's an error. It's not working.
Okay, let me. It's supposed to be working. Let me try to send another one. Did you get it?
Where are you sending it, sir?
I forwarded it to WhatsApp.
Yes, it's working.
It's working.
Yes.
So, you know what you must do? Turn off the sound of the YouTube.
Okay.
Did you turn it off?
Yes, sir.
Okay. Where's your sister?
She's coming by. She's coming downstairs to me. Her site's not working.
Okay. Tell me when she's there.
Yeah.
So I'm sure it will not correlate the streaming of your app Teams and also the YouTube.
Sorry, sir?
But I'm sure it will be the YouTube one and this one will be seconds apart, ne?
Okay, sir. That's fine.
Yeah. But I think we will do our lessons like this until this whole COVID-19 thing goes away.
Yes, sir.
Do you think it's gonna go away very soon?
I hope so, sir.
It has to. It has to.
Because missing out on school is not nice.
I know. And I'm sure you miss your friends and everyone.
Yes.
Yeah. Okay. And I hope you're still doing your 1 hour.
Yes.
Yeah, it's very important. It's very important. Look, so far, Konje, which topics did we cover the last time?
We covered functions.
We have not yet
Covered
done
surds.
functions.
And sorry, not functions, inequalities and surds.
Inequalities and surds, right? We did 3 topics
Yes.
that day, and also solving equations that have fractions. You still remember that?
Oh, yes.
Yes. And then with inequalities, you still remember what we do when we solve them?
Yes, sir.
Yeah.
Yes.
There's another way I want to show you how to factorize, and I think it's easy and quick.
Okay.
Yeah. Let's say we have the following: 2x minus 3 into x minus 4. Is the YouTube behind, no?
It's working well.
It's working well. It's correlating well.
Yeah.
Okay. If you have this, normally if you are going to solve an expression like that, you are going to use what we call what? The FOIL method. Do you see that?
Oh.
And the FOIL will tell you this right here is an equation on its own. It's a binomial, and that is a binomial. Do you see that? So if that's
Yes.
the case, this is going to be the first term, and that will be the last term of that first binomial. This is going to be the first, and that will be the last. Okay?
Yes.
And at the same time, these 2 terms here are the outer terms of that whole thing, and these 2 terms are the inner terms. Right?
Yes.
And from there, FOIL suggests that the first 2 terms will multiply each other. And when we multiply the first two terms, we're going to get 2x squared. Do you see that?
Yes.
And when we multiply, and then FOIL also tell us that the next thing that we're going to do is to multiply the outer terms. And when we multiply the outer terms, we're going to get 8x. Do you see that? And the next thing, we're going to multiply the inner terms, which is going to be minus 3x. And thereafter, we are going to multiply the last terms, which is going to be plus 12. But if you were to continue, what can you tell about these terms?
There's two like terms.
And what happens when what happens with those terms?
You add them.
And then when we add
Or
them,
you can group. Can you not group?
like now we're no longer grouping. We're going to group if we were factorizing. Remember, now we are moving from factorizing to the simplified form. And factorization goes from simplified to the factorization. Do you see that?
Yes.
So this is now going to be minus 11x plus 12. So which means if you were to factorize to that, you were going to get it as, do you see that? Are you following?
Yes.
So now, when we factorize, I have another method you can use to factorize. One of the easiest methods. You are going to follow FOIL. So let's say we have here now, what's the equation right there?
Sorry?
What's the equation that we have on the screen? I just want to check if it's correlating.
It's 2x squared minus x minus 3.
That is the equation that we have. And if we are going to factorize this using FOIL, we can just, we know that the quadratic equation, when we factorize, it's going to have two brackets. Okay? And within the brackets, we are going to have two binomials, right? So what we're going to do first, we need to break down that according to its factors. And if we are going to break it down, this is the same as 2x and x. Are you following? And the next step that we're going to take is to take the coefficient of x squared, we still multiply it with that. And we're going to get minus 6. Right?
Yes.
And once we get minus 6, we are now going to look for the factors of minus 6 that will give us minus 3, minus 1. And those factors are going to be what?
2 and 3.
It's going to be? It's going to be 2 and 3.
Minus 3 plus 2.
It's going to be 2 and 3. We can first look for the factors of 6. And once we get the factors of 6, remember, because this is negative, the bigger number must get the negative. Okay? So basically, this is now going to be 2x minus 3x. When we add the 2, it's going to give us what? Minus x. So now, this is what we're going to do. We are going to look between these two factors, 2x and minus 3x. We are going to look for one that can be divided by that. The one that can be divided by 2x, that will not leave a remainder. Which one is it?
So please repeat.
We are going to look for the fact between these two numbers. We are going to look for one that will be divided by 2x and it leaves no remainder. Which one is it?
2.
It's 2x. So if we divide 2x by 2x, we're going to get plus 1. Okay?
Yes.
And if we divide minus 3x by x, we're going to get minus 3. And that is factorized.
Please repeat that, sir. I'm not catching that.
Let me do another one. Let's say we have 3x squared minus x and minus 2. And we need to factorize. First thing first, we know that we are going to have two brackets like that, right?
Yes.
So the first thing that we're going to do, we're going to look for the factors of 3x squared in terms of x. What will be those factors?
1 and 6, 2 and 3.
We're talking about the factors of, we need to break down that according to its factors. In terms of
3.
x, it's going to be 3x, and we're going to have x there. Do you see that?
X.
Right?
Yes.
Because when we multiply these two, we are going to get what? 3x squared. So now, the next thing that we need to do, we are going to take the coefficient of x, we multiply it with a constant term. And what do we get?
Negative 6x.
Negative 6. I got. So from here,
Yes.
the next thing that we need to do, we need to look for the factors of 6, negative 6, such that when we add them together, they're going to give us negative 1. What are those factors?
1 and 6, 2 and 3.
So we have 1 and 6 and 2 and 3. And because this is negative, the bigger number must get a negative, right? And the factors that we were looking for, you will realize are those. And now you need to break this down like this. Negative 2x and negative 3x will give you negative x. Ahisha, do you get it up to this point?
Yes.
And then from there, you're going to compare between these two. Which one between these two factors, that when you divide it with 3x, because this must multiply that. Remember, FOIL. The first two terms must multiply, we're going to get 3x. But the outer terms must multiply, and when the outer terms multiply, we are going to look for what we can multiply with this to get 3 minus 3x or plus 2x. Do you see that? So we are going to look for a number, we are going to look between these two, we are going to look for one that when we divide it with 3x, it leaves no remainder. Which one is that between the two?
3x.
It's 3x. So if we say negative 3x divided by 3x, what do we get?
Negative 1.
So this is going to be negative 1. And 2x divided by x, what do we get?
1.
It's 2.
2x
divided by x, we're going to get 2, right?
Sorry, yes.
And this is going to be plus 2. And that way, that expression has been factorized.
So, I have a question.
Yeah.
How do you know, so like you divided 3x by 3 to give you 1. How do you know in which bracket to put it?
Because the first thing, FOIL tell us that we're going to multiply that. So we're going to put it on the outer part.
Oh.
We're following FOIL.
So when you multiply the bracket out, it must give you the original equation?
Yes.
Oh, okay.
Remember, that is factorization. This is another part. I don't want you to stress more about it because the other one might be easier for you, but I think this is quick and easy because it can take you a minute to do all of that, while the other one can actually go for 2. Ahisha, can we do another example?
Yeah, we can.
I see you look lost.
I'm lost at the first bracket.
Okay. You see that equation right there?
Yes.
It needs to be factorized. So we know that at the end of it all, if we factorized it correctly, we're gonna have 2 brackets, right?
Yes.
So the first step, we're going to look at that. What we do with this, we're going to break it down to its factors in terms of x, right? So we are going to have right here 2x, and we're gonna have x right there. Do you see that?
Yes. Mm-hmm.
And then the next step, we take the coefficient of x, we multiply it with the constant term. And what do we get?
Negative 6.
Negative 6. And thereafter, we are going to look for the factors of 6. Leave the negative aside because you are going to assign your negative when you check which number is in the middle term. Is it positive or negative, right? So the factors of 6 will be 1 and 6, 2 and 3. But since the middle number here has a positive, it means the bigger number must get a positive sign. So this is now going to be negative and positive, negative and positive. But obviously, these are not the factors we're looking for. We're going to work with those factors because when we add them, they give us 5x. Do you see that?
Yeah.
So we might as well put them like that. Minus x plus 6x. Right?
So, where did you... Oh, yes, I see it. Okay.
Minus x plus 6x. And therefore, you are going to look which of these two that when you divide them by 2, it leaves no remainder.
6.
It's
Negative
6.
X.
It can't be x because negative x divided by 2x, it's going to give you 1 over 2. Do you see that?
It's 6x.
It's
2x
6x.
divided by 6x.
So we're going to say now 6x divided by 2x. What do we get?
3.
And that goes to the outer term because this is the first term. And the next step, it's going to go to the outer term. So it's going to be plus 3. Do you see that? And the next one, we are now going to say minus x divided by x. What do we get?
X.
It's minus 1. It's minus 1.
Where are you getting the X here? No, remember he divided that by that. And then he was left with X.
Now let her ask the question.
So, I know, so you said 2x divided by 6x gives you 3, okay? I got that part.
Yeah.
Then, where did you get the x from to divide by minus x?
It's that x.
Oh, now I understand.
You get it now.
Yes.
Yeah, let's do. So now you are going to do the following and you show me the answer right there, each and every one of you.
Okay.
Using this method.
Okay, sir. Okay.
You got it?
Yes.
Let me see. Yes?
I'm stuck with the second one. It's
Okay.
hard to get.
Okay, if you're stuck, we're going to do corrections. And then you're going to see where we're going to unstuck you. Let me see yours.
Okay. Okay. Can you see?
Yes, I can see. That's brilliant. You did it. So now let's help your sister there. So we are going to have 2 brackets like that. We are following FOIL, remember? And in FOIL we start with the first term. So we are going to look for the factors of the first term according to x, right?
Yes.
Which is going to be 2x and x. then you take the coefficient of x, you multiply it with the constant term, and you're going to get minus 10, right?
Yes.
And thereafter, you're going to look for the factors of 10. It's going to be 1 and 10 and 2 and 5. And simply because this is minus, it means the bigger number must get the negative sign, right? And then this is, so the factors that we're going to work with, it's that one. This is not it, because when we subtract that, we get minus 9. But when we subtract that, we get minus 3, right? So this is the same as 2x minus 5x. Because now we are going, according to FOIL, we're going to work with the outer terms. And the outer terms are these two. It means whatever we're going to do, it goes to the other bracket. Do you see that?
Yes.
So we are going to look between these two factors. We are going to look for one that when we divide it with 2x, it leaves no remainder. Are you following? And that will be 2x. And 2x divided by 2x will give us a positive 1, right?
Yes.
And again, we are going to divide the other one by x. So minus 5x divided by x, it's going to give us minus 5.
Oh.
And that way it is factorized. Do you see how quick it is?
Yes.
And you do
I
not...
like this method.
You like this method? Okay.
Yes.
So I'm doing this because in an exam, if you forget one method, you might as well remember the other one. If you forget both of them, then forget the distinction.
Then you do.
Are you following? You're doomed. Yeah, that was the word I was looking for. So I was doing that because you have noticed that even with factorization, even with inequalities, it will require you to factorize. When you solve for x, you're going to factorize. When we get to functions, you will realize that to look for the x-intercept of any graph, you need to factorize. Are you following?
Yes.
So today I want us to look at exponents, basically. And maybe in exponents, we are also going to factorize. Everything it boils down to factorization, especially of quadratic functions. Do you remember the exponential rules?
Yes.
Name 5 that you know.
So
I'm
when
gonna
you
start.
divide-
Yes.
When you divide exponents, you minus them. When you multiply, you add them. And only when they like terms, then you can add the
Okay.
exponents.
Okay. But we need to make them sound. We need to make those statements sound mathematical. Ne? Because we are going. I told you the last time that mathematics, it comes down to 4 basic principles. It's either you add or you subtract, you multiply or divide. So if we are going to introduce a topic like exponents, there will be a rule that will tell you that when you add the exponents, this is what you must do. When you subtract exponents, this is what you must do. When you divide exponents, this is what you must do. And when you multiply exponents, this is what you must do. Are you following? But remember, exponents, if you're going to talk of exponents, if you happen to have a to the power x, this is the whole of that, it's called the power, right?
Yes.
The whole of that, it's called a power. And in a power, you're gonna have a base, and you will also have what? An exponent. Are you following?
Yes.
So if you have powers like that, you need to know how to divide powers. You need to know how to multiply powers. You need to know how to add and subtract powers. Are you following? With addition and subtraction, we're not gonna focus that mainly on that, because we know that if the terms are not if we do not have like terms, we cannot add or subtract. Are you following? For instance, if you happen to have x squared plus x, are those like terms?
Yes.
No, they are not like terms.
No.
They are not
But
the
they
same.
both
The other one have exponent 1, the other one have exponent 2. So they are not the same. Remember, when we talk of like terms, we're talking of same terms.
Oh, yes, okay.
Are you following? But if you happen to have x squared plus x squared, then this can be added, and this is going to be 2x squared, because you have 1x squared and 1x squared. Because the terms are like, they can be added. But if you happen to have x cubed plus x squared, are those like terms?
No.
No. And these are exponents, because here you have a base and there you have an exponent. Do you see that? And the whole of that is called what?
A power.
It's called the power. So we're going to look into that. So everything have a rule. I'm going to start with the multiplication rule. The rule states that if powers have the same basis, if you multiply powers with the same basis, then you can add the exponent. Did you hear that statement?
Yes.
So they are not saying if you multiply exponents. They are saying if you multiply powers with the same base, you are going to add the exponent. And that can be given by, if you have x to the power m multiplied by x to the power n. Do you see that you have two powers there?
Yes.
What are those powers?
M and n. X to the power of m and x to the power of n.
Remember, the whole of this is a power, and the whole of that is a power. Are you following? So here we are multiplying powers. But the most important thing that you must look at is that these powers must have the same base. Do you see that? So this is, do they have the same base?
Yes.
So if they have the same base, they say you must add the exponent, which means you keep the base and then you add the exponent. That's the first rule that I want us to look at.
Okay.
But I also want us to look at, what if we multiply powers that have the same exponent but different bases? Because that is also important. Are you following? For instance, what is the answer? 2 multiplied by 3. What's the answer there?
6.
6. Okay. Have you noticed that 2 is the same as 2 to the power 1 and 3 is the same as 3 to the power 1?
Yes.
So these are powers and they have same exponents. Do you see that?
Yes.
Which means, what can you tell me about the rule we have utilized? Let's see if you can think and you can observe. You agree that this and that is these are powers.
Yes.
And this is basically 6 to the power 1. What can you tell me? What pattern do you see there? Can you notice a pattern there?
The exponents are the same. I don't know.
Notice, do you see that the exponents are the same?
Yes.
Then we multiply the bases and kept the exponents. Do you see that?
Yes.
Which means there is a rule that states if the exponents are the same, when you multiply powers with the same exponent, you can multiply the bases and keep the exponent. That's what it means.
Oh, I never heard of this. I never heard of this rule.
But you use it every day. Like when you multiply 3 multiplied by 5. This is the same as 3 to the power 1 and 5 to the power 1. And you say the answer is 15. And it's 15 to the power what?
1.
Which means if the exponents are the same, you can multiply the bases. So if you multiply powers with the same exponents, you can then multiply the bases and keep the power. look at where I'm going. Pay attention to where I'm going. What if you have 3 to the power x multiplied by 5 to the power x? What is the answer there?
15 to the power x squared. No, 15 to the power x.
It's going to be 15 to the power x. Why is it x squared?
Why is it x squared? That won't be 1 squared, would it? 15 to the power 1 squared.
So basically, do you see where the rule was going? So it means you can multiply the bases and keep the powers. So which means there is a rule that will tell us that we can have 3 multiplied by 5 to the power x, which is going to be 15 to the power x. Let's do another example. Take out your calculators for this one.
Okay.
What's the answer there?
9 times 20. Yes. 21. 21 squared.
21 squared.
Yes.
And what is 21 squared?
441.
441. Can you put that in a calculator and see what you get? All of that.
441.
So do you see that rule applies?
Yes.
So there is a rule that they will never teach it. They hardly teach it in at school. So they hardly make you recite it. But it is a rule that you have been using all your life. When you multiply numbers, this is what you've been doing. But I want you to look into this. Let's say we have 10 over 2. This tells us that each and every number can be written as an exponent. Do you notice that? Any number can be written as an exponent. It doesn't matter what the number is. So normally we're going to say this is the same as 5.
Yes.
Which means what happened there? This is 10 to the power 1 and 2 to the power 1. It comes back to that rule that when you divide powers with the same exponent, you divide the bases and you keep the exponent. Did you see that? So
yes.
Even if you had 8 to the power x over 2 to the power x, these can be written as what? Because the exponents are the same, you're going to keep the exponent and then you divide the bases. Are you following?
Yes.
So
yes.
You need to remember that rule. So let's move to the next rule. It's not something that it's always there. You will see. It's forever there. You have been doing it since grade 8. It's just that nobody ever formulated it and they taught it like that. Are we clear? Oh, Konje, you were not in the South African school curriculum. Sometimes I forget. I'll get with the time. So the next one, when we divide powers with the same base, we subtract the exponents. Are we clear?
Yes. You multiply.
Oh, sorry. Thank you. When you divide powers with the same base, you subtract the exponents. And then you understand that rule, right?
Yes.
And there is another one, the one that we should have started with. Anything to the power 0
is 1.
Is 1. Anything to the power 0 is 1. And there is another rule that if you are going to raise a power to a power, you are going to multiply the exponent. Do you see that you have 2 powers there?
Yes.
The first power is 2m. This is a power on its own. And the second power is 2. This becomes now the base and the exponent is n. Do you see that? So,
Yes.
yeah, so if you raise a power to the power, let me have this as x. So if you raise a power to a power, you are going to multiply the powers, which is going to be x multiplied by n, which is going to be x to the power mn. Are you following?
Yes.
These are the most critical rules you are going to follow when you work with exponents. You are going to do them all the time. But when you're doing all of this, you need to remember that there is the order of operation, BODMAS, all the time. Are we clear?
Yes.
So all the time we're going to do BODMAS. It does not change because now you're working with exponents, which means if you have exponents that have brackets, the first thing you're going to work with is the brackets. Are we clear? So now let's look into this. Another important part of exponent is that before you work out with anything, before you even start to apply the rules, it is very important to make sure that all the bases are in their prime base. Are we clear?
Okay.
And your calculator will be able to give you prime bases. For instance, if you happen to have 12 to the power n, we have a base which is 12, okay?
Yes.
And 12 is not a prime number. Do you see that? Which means before you even start doing anything, you need to change the base to be on its prime. Remember what I showed you on your calculator, how you can find the factors? The calculator normally will write the 12 as its prime factor. And if the calculator writes 12 as its prime factor, it's going to be 2 to the power 2 multiplied by 3. Do you see that?
Yes.
Which is going to be to the power n. So if you have something like this, it means you are raising this power, you are raising that power to that power, and again you are raising that power to that power. Which means this can further be written because if you raise a power to a power, you multiply the exponents, okay? Which means this is going to be 2 to the power 2n multiplied by 3 to the power n.
Okay.
Are you following? So that's how you can write a number on its prime base. So all the time, you need to make sure that the composite base is changed to its prime. Even before we start applying the rules. So I'm giving you the first step to working with exponents. Every time, whether it is equation, whether you are simplifying the exponents, anywhere, the first thing you need to do is to make sure that is to check if you have the composite bases. You know what are prime numbers, right?
Yes.
What are prime numbers?
Anything that can go into itself and something else?
A prime number is a number that can only be divided by 1 in itself and it leaves no remainder. So if you look at this, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. Is 9 a prime number?
No.
Because it can be divided by 1, 3, and itself without leaving a remainder. So 9 can't be a prime number. So every time when you have a base, you need to check, are there composite bases? If there are composite bases, you then have to change the composite bases to prime bases, and your calculators will help you with that.
I have a question.
Yes.
What is composite basis?
A composite base is like a number that cannot only be divided by 1 in itself. It can be divided by more than 2 numbers and leaves no remainder. So look at this. Look at this. Can you please write this on its prime basis?
So it's 3n. Yes. Prime basis. It's 3n.
Nah, it can't be 3n.
No, wait, I'm going to tell you. What you mean? It's 2n times 3n.
Because when you break down 6 to its prime basis, it's going to be 2 to multiply by 3 to the power n. So when you write this on its prime basis, it's going to be 2n multiplied by 3n.
3n.
Are you following?
So when you say prime basis, it's two numbers that will give you that answer.
Sometimes 3.
Sometimes 3.
What is, well, let's say we have 24x. Write that according to its prime basis.
So it's gonna be 24. 4 and 6. Wait, so it's 2 to the power of 3n times 3n will be your answer.
So it's gonna be 2 to the power 3n times 3n.
3n.
Are you following? So we have numbers that have more than 2 prime bases. For instance, check 32. What are the prime? No, it's gonna be 2 to the power 4. 32 will be, check 48 will be, now check 52. How many prime bases will 52 have?
2.
2. I'm trying to check 108.
2.
Okay, check 38.
2.
Check that one. 30.
3.
So if you happen to have 30 to the power x and you have to write that on its prime basis, it's gonna be 2 to the power x multiplied by 3 to the power x multiplied by 5 to the power x.
Oh, I see it now.
I'm getting the laptop charger. I'm coming. Almost up. I'm back. Yes, as I was saying, it is. I can see you now. It is important for you to know how to change prime numbers, composite basis of exponents to their prime basis, because before you do anything, that is the first thing that you need to do. Are we clear? For instance, let's say we have to solve the following. 3 to the power x multiplied by 25 to the power x plus 1 all over 3 to the power x minus 2 multiplied by 5 to the power 2. Look at this. It looks like a big elephant, but in reality it's not. If you are going to follow the steps, I said before you start applying the exponential rules, what do you have to do?
Check for the composite numbers.
Okay, do we have a composite base there?
No. But yes, 25.
It's 25. So we need to change that. We also need to consider BODMAS. But before we consider BODMAS, we have to change the composite base to its prime base. And that will be 5 to the power 2, okay? So
Yes.
basically we're going to have 3 to the power x multiplied by 5 to the power 2, but that we now put in a bracket, right? Into x plus
Yeah.
1. All over 3 to the power x minus 2 multiplied by 5 to the power 2. Are you following?
Yes.
And according to BODMAS, before we even start to apply the rules, we are going to deal with what?
Brackets.
So we're going to have 3 to the power x multiplied by. So we are raising a power to a power. It means we're going to multiply the powers, which is going to be 5 to the power 2x plus 2.
2.
All over 3 to the power x minus 2 multiplied by 5 to the power 2. Right?
Yes.
And then from here, following the BODMAS, we are going to divide, right? And all of that line, it's a division. So you can see you have the power there that have the same base. And when you divide the powers with the same base, you subtract.
Exponents.
Which means this is going to be 3 to the power x minus 2 multiplied by 5 to the power 2x plus 2 minus 2. Do you see that?
Yeah.
Which is going to be 3 to the power x minus x plus 2 multiplied by 5 to the power 2x plus 2 minus 2. And that will eliminate, and that will eliminate, and we are going to have 3 to the power 2 multiplied by 5 to the power 2x, which is going to be 9 multiplied by 5 to the power 2x. Are you following?
So wait, the video was loading still.
It's still loading now.
No, it's fine now. It was loading while you were talking.
Oh, okay. So look at this. From here, I erased that. Is it loading now?
Yeah, it's fine.
It's fine now. So here we're going to have 3x minus x plus 2 multiplied by 5 into 2x plus 2 minus 2. That and that will eliminate each other. Do you see that?
Yes. Yes.
And this is now, we're going to be left with 3 to the power 2. And again, that and that will eliminate each other. And we are going to have 5 to the power 2x. But when we simplify this, we are going to get 9 multiplied by 5 to the power 2x. And that way it's correct. Why are we not putting 2x, all of that? Because when we simplify exponents, we must always make sure that they are in their prime bases. Am I making sense?
Yes.
Let's do another one. Let's say we have that. Do you see that?
Yes.
And we need to simplify it. What's the first thing that we're going to do?
Composite numbers.
We have to change the composite base to its prime base, right? And what are we going to get there?
3 squared times 5.
So this is going to be 3 squared times 5 to the power x plus 2 multiplied by 7x. Because 7 is already a prime number, right?
Yes.
And this is now, we're going to divide that by 5x multiplied by 3, 2x multiplied by 7x. So if you were to continue with this, you'll realize that now you are going to raise a power to a power. And when you raise a power to a power, what do you do?
It's going to be 3 to the power of 2x plus 4
Yes.
times 5 to the power of x plus 2 times 7x. Times 7x over
Yes.
the rest of it.
Good. So we might as well divide that and we cancel it out.
Yes. Yes.
And now we are going to divide powers with the same basis. Do you see that?
Yes.
And this is now going to be 3 to the power 2x plus 4 minus 2x multiplied by 5 to the power x plus 2 minus x. Do you see that?
Yes.
Which is going to be 3 to the power 4 multiplied by 5 to the power 2. Am I right? Are you still following?
Yes.
And then this is now going to be 81 multiplied by 25, and use your calculator to get the final answer.
So the 2x, you took it from the bottom x number, right?
Yes, that.
Oh, okay. It's so easy.
It's easy.
Yes.
It means now we can do some work, right?
Yes.
Okay. I have something for you that I want you to sort out. I'm trying to open a question here.
Okay.
And such questions, when they ask them in exam, this is how we mark it. For changing
So
the...
how many marks?
Yeah, I'm gonna show you now. For changing the composite base to prime base, you're gonna get a mark for it. For raising a power to a power, you get a mark for it. For applying the exponent when you divide the powers of the same base, you get a mark for it. And you're gonna get a mark for the final answer. So this should come with 4 marks.
Wow.
Are you following?
Yes, sir.
I'm gonna give you something that you're gonna do now. And then when you're done with it, you're doing it separately.
Yes. No. So is that A?
Yes, it's A. My handwriting is horrible, I warned you.
No, sir, it's not. It's neater than mine.
I comfort myself every day that as a teacher, I've seen worse. So you're doing that one, and you will see how easy it is. If they were to ask you questions in an exam, it would be that. Let me give you a second one when we're still at that.
I'm going to go fetch my calculator. I'll be back.
Okay, all right. So do those two. I just want to get something to drink. I'm coming.
Okay, no problem.
Yeah. So remember, you follow the steps. The first step, you follow before you make sure that all the composite bases are turned to the prime base.
Yes.
Then you apply the it's those two, and then after that we're gonna do corrections, and we move to the next one.
Okay.
Yeah.
What is it? What happened when you have seen over here? Then you subdivide and then you add the bases. Is that
Are you guys done?
busy with number 2?
Okay.
I'm so busy with number 1.
I understand. You went to fetch a calculator.
Yes, sir. Sir,
Yes.
when you're taking the exponents from the bottom. Okay, never mind.
Okay.
done.
You're done.
Yes.
Let me see number 1.
How do I turn this camera? Aisha. How do I turn this camera? Okay.
The final answer?
It's 2 to the power of a times 5 to the power of negative 4 over 3 to the power of a minus 2.
There's some steps you missed. We're gonna do corrections.
Okay. So can I show you my first answer?
Let me see.
But I'm still busy with the second one, right?
Let me see the first one.
Can you see?
Nope, you missed some steps as well.
Which steps?
Let's do that one quickly. We're gonna come back to number 2. Right?
Yes.
We have right here 12a plus 2 multiplied by 10 to the power a minus 2 all over 8a multiplied by 15a minus 2. I think this is where you went wrong. You were too quick to divide before you add and multiply everything that is on the exponents. And also you multiply everything that is on the denominator, numerator and the denominator. But look at this. First thing first, you're going to make sure that the composite bases are changed to prime bases, right?
Yes.
Which is 2 to the power 2 multiplied by 3 to the power a plus 2 multiplied by 2 multiplied by 5 to the power a minus 2. You can't get that wrong. Your calculator will help you. Are we clear? So all of this will be divided by 2 to the power 3 to the power a multiplied by 3 multiplied by 5 all to the power a minus 2. And if we were to continue, we are going to get 2 to the power 2a plus 4. Did you get that?
Yes.
Multiplied by 3 to the power a plus 2. Did you get that?
Yes.
Multiplied by 2 to the power a minus 2. Multiplied by 5 to the power a minus 2.
Oh, no, never mind. Yes. Yes.
And then we divide that by 2 to the power 3a multiplied by 3 to the power a minus 2 multiplied by 5 to the power a minus 2. So the next thing we're going to do when we here, look at this. We are multiplying the bases that have the same, the powers that have the same base. Do you see that? So before we go and divide, we make sure that the numerator is sorted and the denominator is sorted. There's nothing that can add or multiply. Are you following?
Yes.
So when we multiply that, we are going to get that 2a plus a, we're going to get 3a. Are you following?
Sorry, where did you get 3a?
Because when we multiply powers with the same basis, we add the exponents, okay?
Oh, yes.
So 2a plus a, we're going to get 3a. And 4 minus 2, we're going to get 2.
Yeah.
So because there is nothing that can be multiplied with 3, we write it the way it is. And then we sort it out like that. Oh, so that's the step you missed.
Yes.
Yeah, I thought as much. And then from here, then you are dividing powers with the same base, because each and every power here have the same base. Do you see that? And then from there we can say 2 to the power 3a plus 2 minus 3a Do you see why I'm getting all of that?
So,
Yes.
can't you cancel out the 5a to the power 5a minus 2 over 5a minus 2?
Why don't... So this is now going to be 2 to the power 3a plus 2 minus 3a multiplied by 2, or 3 to the power a plus 2 minus a plus 2, which is, that will cancel that. We're gonna be left with 2 to the power 2, and that, and we're gonna be left with 3 to the power 4. And this is going to be 4 multiplied by 81. But from here, use your calculator to get the final answer.
Okay, so.
Yeah. Look at this. It's pretty long, ne?
It's long, yes. Okay, so I'm going to do the second one quickly.
Okay. You want to do it quickly?
Yes, sir, please.
Yes, do it quickly, and then we're going to do the corrections. You're going to have negative exponent. It's fine. We're going to work it out. If your answer is negative exponent, leave it at that. We're going to work it out.
Okay. Okay.
You're done. You were so quick. I'm still doing it. You were quicker than me.
Oh, I already started with it. I was just finishing it.
Oh, okay.
Yes.
Was a negative exponent 2 to the power minus 4 and 5 to the power minus 1?
Yes. 2 to the power?
2 to the power minus 4 multiplied by 5 to the power minus 1.
I got 2 to the power 6.
2 to the power 6. Okay.
Oh, well, they're supposed to simplify my exponent.
Yes, you have the you simplify the numerator. Whatever is on the numerator, you simplify it, and whatever is on the denominator, you simplify it. Can we do corrections?
Okay, then I got it.
Let's do corrections.
Yes.
So look at this. Composite basis to prime basis.
Oh my god.
Oh, you saw your mistake.
No, I got it right.
You got it right. So
Yes.
look at this here. This is the same base, that's the same base, and we are multiplying. Do you see that? So we need to simplify that part. And this is the same base, this is the same base, and we are multiplying. We need to simplify that part before we divide the whole thing. Are you following?
Yes.
Which is going to give us 2 to the power 2 minus 2x. Am I right? Or maybe let me do it like this. We're gonna have 2 to the power 4x minus 1 plus 3 minus 6x multiplied by 5 to the power 4x minus 1 all over 2 to the power 4 plus 2x plus 4 minus 4x multiplied by 5 to the power 4x. Right?
Yes.
And from this, we are going to get 2 to the power minus 2x plus 2 multiplied by 5 to the power 4x minus 1, which will give us 2 to the power minus 2x plus 8.
Really? Plus 8. 4 plus 4 is 8.
Is 4x. 2 to the power minus 2x plus 8. Am I right? Multiplied by 5 to the power 4x. And this is going to be 2 to the power negative 6. Right? Multiplied by 5 to the power minus 1.
Okay.
Is that correct? You got it? Who got it?
No, I made a mistake.
Where was the mistake?
By the second step, what step is it?
We have 1, 2, 3, 4, 5. Which one?
Wait, 1, 2. The second step, I don't know. If you look at the first step, the denominator, which 2 to the power 2 bracket 2 plus x. I don't know where I got 44.
Where you got?
The first step, the second step, I didn't multiply my exponents properly.
Oh, okay. You were supposed to get 2 to the power 4x plus 2x.
Yes.
That's the common mistake that most learners make. And please do not Do not make it. You're gonna lose marks. Let's do another example then.
Yes. Right. Do this. I see it. You also just I just
Guys,
Sir, something's wrong.
you see where I said 4x plus 2, 4 to the power x plus 2?
Yeah,
Make that to be b, I'm sorry.
that's That's why it's not working out.
Make that to be B. I'm sorry.
The X is right. It's supposed to be D. That's why I'm struggling here. That makes sense. And then also, we don't have a 5 at the top. We only have a 5 at the numerator.
You only have?
Okay, no, wait. Let me work it out. Ish.
I'm sorry about that. But I'm glad you could see it was not working. It means you understand it.
Yes. Okay, this is 2B. So all the X's changes to B. And what you do is yeah. Try this whole step is to change it. So that's just 2. Okay. I'm done.
You're done.
Yes.
What's the answer?
4 or 5. Yes.
It's 4.
4 over 5.
4 over 5.
Yes.
Where did you get the 5?
Oh, wait. Anything to the power of 0 is 1.
Yes.
It's not 0.
It's
5
1.
is to the power of 0, so it's 1. So it's 4 over 1, which is 4. Oh, it doesn't have anything. Okay, so then it's 4. Okay, I got it.
We're almost there. Awesome.
It's 4.
The answer is 4. So do you see how easy this is? So I want us to look at the negative exponent.
Okay.
It's one final rule we did not do, because I wanted us to work with things that have negative exponent, and then you see how we can work around it. Let's say we have 2 to the power negative 2. The negative exponent will be like this. We first have to change the negative exponent to positive. So we need to know how to change the negative exponent to be positive. Are you following? And for this to be positive, everything now relies on the base. So it means we need to find the inverse of the base, and we change the base to its inverse, and then we change the negative to its inverse. Konje, what is an inverse?
It's the opposite.
It's the opposite.
The negative of it. The other way around.
Look at this. When you multiply 2 inverses, the answer must be 1. Am I making sense? Which means the inverse of 2 is 1 over 2. The inverse of 1 over 2 is 2. The inverse of 3 is 1 over 3. So basically, when we talk of an inverse, the inverse of left is right. The inverse of up is down. The inverse of the numerator is the denominator. Am I making sense?
Yes.
So the inverse of 10 is what? 1 over 10. The inverse of 20?
1 over 20.
Exactly. So if we happen to have 2 to the power minus 2, it means we need to change. We need to find the inverse of the base and the inverse of a positive. Are you following? A negative. So what is the inverse of the base?
1 over 2.
So this is going to be 1 over 2 to the power 2. That's it.
Okay.
That's how you change negative exponent to be positive exponent. And this can be simplified further because this, you are raising a power to a power. Do you see that? So this is going to be 1 over 4 because this is the same as 1 to the power 2 over 2 to the power 2. Are you following?
Yes.
Which is going to be 1 over 4. So look at this. Look at this. If you happen to have 4 to the power negative 2, what must you do? You find the inverse of the base and you change the sign of the exponent. So this is the same as 1 over 4 to the power 2. Do you see that?
Yes.
Which is going to be 1 over 16. It's that easy. But look at this. So let's say we have 3 over 2 to the power negative 3. You have to write the inverse of the base. What would be the inverse of the base there?
2 over 3.
So this is going to be 2 over 3 to the power 3, which is going to be 8 over 27. You know how we got the 8 and the 27, right?
2 to the power of 3 over 3 to the power of 3.
Good. So answers that have the negative exponent, they are not fully factorized. They can only be fully simplified, I meant. They can only be fully simplified if and only if the exponent is positive. Let's look into this. You had 81 minus 1 there. Did you see that?
Yes.
Which means to make this to be positive, it's going to be 1 over 81 to the power 1. Which will lead us to 1 over 81. Am I making sense?
Yes.
So all the exponential rules are explained. You have one that deals with the power 0. You have one that deals with the multiplication and division. And you also have the negative exponent. And from now, you should know how to simplify exponents. I feel like we should do another example. What do you think?
Okay. Yes, I'm happy with that.
And then we can move to the next one. And tomorrow at 11, do you have anything?
No, we'll ask it tomorrow. Sir, can we let you know after the call?
Okay, all right.
Thank you. Because we usually have English at 11.
Oh, with Ma'am Ramsey.
Yes.
A very good teacher.
She is very good, sir.
I worked with her very well.
That's nice.
She was one of my close colleagues. We're gonna do this one. It looks difficult, but I'm gonna explain a concept,
Okay.
before we do it. Right?
Okay.
Look at this. Look at this right here. If you happen to have the cube root of 8, the first thing that you need to do is to change 8 to its because 8 is a composite number, but 8 can be written as its prime number, okay?
Yes.
Which is going to be the cube root of 2 to the power 3. But look at this. If you have 3 there and you have 3 there, This, it can be written as an exponent as 2 to the power 3 over 3, which can be 2. That's why the cube root of 8 is equal to 2. I just worked it out without the use of a calculator. Can I explain something further?
Yes.
Look at this. If we have, okay, forget that one. Let's say we have the square root of 4. If we have the square root of 4, we know that there is automatically 2 there, right?
Yes.
So basically, this as an exponent, because cubes or squares can be also written as an exponent. You know that, okay?
Yes.
So now, to work this out,
Hello?
hello, I'm still here. To work this out, we can say this is the same as 4 to the power 1 over 2. Whatever is here, this can be written as an exponent. And this becomes the denominator that becomes the numerator. Are you following?
Yes.
But 4 to the power 1 over 2, it's going to be 2. Look at this. This is why the square root of 4 is 2, because now we know that this is the square root of 4. We know that here there is automatically 2. But 4 is a composite number, which means it can be written on its prime number. Are we clear?
Mm-hmm.
Which means now we are going to have the square root of 2 over 2. And now this is going to be the numerator, and whatever is here is going to be what? The denominator of the exponent, which means this is the same as 2 to the power 2 over 2. And 2 over 2 will give us 1, and the answer is 2. That's why the square root of 4 is 2.
2.
Am I making sense?
Yeah, yes.
So it is very important for you to know how to change the cubes to exponents, and to know how to change exponent to cubes. Look at this. If you happen to have x to the power 2 over 3, you can write that as x to the power 2. This and that is the same thing.
Oh, I see.
Do you see that? Look at this. This is the same as x to the power what?
1 over 4.
Aisha, can you see that?
Mm-hmm. Yes, I'm following.
And then if can you write this as a cube? Then if you're following, write that in a root form, and you show me.
Okay, I can do that.
Yeah, let's do it.
So can I show you? Can I show you first? Wait.
Take it up a bit. Awesome.
Let me see. I got it.
You got it. So it means you can do that one.
Yeah, yes.
Let's do that.
Why is my God? Okay, so I think I got it.
Let me see. The last step.
Yeah.
It's incorrect.
Why? I'm confused.
We'll do corrections then. I'll unconfuse you. Let me see yours.
You shouldn't complete it. I didn't complete it. I don't know what to do with the 1/2.
Let me see it.
Like, I changed it to the prime basis, but I didn't know what to do with that. Because I changed that.
But
What
do
are we doing?
do you see where your mistake is?
No. That's
Yeah.
all my steps correct until the last step, right?
Yes, yours is correct until the last step. Your mistake is that you started to apply the rules before you change the composite basis to prime basis.
Okay.
You skipped a step, and that's what confused you.
Okay.
Maybe
Okay.
let me explain this even furthermore. Because I feel like let's complete this today so that tomorrow we can do equations. Look at this. If you happen to have 4x plus 1, do you see that the exponents are adding each other?
Yes.
What does that tell you? If you can work that on reverse.
What you mean?
Do you see if you multiply powers with the same base, you add the exponent. So if the exponents are added like this, it means there are two powers that have been multiplied.
Oh, so it's 4x and then 4.
Yes, it's 4 to the power x multiplied by 4. That can be broken down like that. This and that is the same thing. Do you see that?
Yes.
So if you happen to have 2 to the power 2x plus 2, pay attention before you start erasing things. This is the same. If you can work it back on reverse, you're going to have 2 to the power 2x multiplied by 2 to the power 2. Do you see that? Ahisha, are you following?
I am.
And then again, if you have 3 to the power x minus 1, it means these exponents have been divided, right?
Yes.
But at the same time, look, it confused a lot of people, this one. I want you to pay attention. We can also work it out as though they have been added. Because when we add this and that, we're going to get that.
Yes.
Are you following? Which means if you have 2 to the power x minus 1, this can also be broken down as 2 to the power 2x multiplied by 2 to the power minus 1. Right?
Mm-hmm.
But this is a negative exponent. So you need to change that to a positive exponent, which we also did. Are you following?
Yes.
So it's going to assist us mainly on tomorrow's lesson, but it's going to assist us here as well. So if I were you, I would have first changed this to the composite base before I apply any rule.
Oh.
Are you following?
Yes.
And then from here, I was going to break this down. I might as well break this one down as well, right?
Yes.
And then from here, I was going to apply that rule that states this is the same as 2 to the power 2x multiplied by 2 to the power 2 over 2x. Do you see that?
So do we have to break it down?
We don't have to.
Okay, because it's confusing me. Can I just do it can I keep it as I did it?
Okay, maybe let's not break it down if it's gonna confuse you.
I understand the concept though. It's just that
That's the most important thing, to understand the concept. Look at this. This is the same as, if you look into this, you have a common factor which is 2.
Yes.
So we might as well write it down with a common factor. Am I right?
Yes.
And then we continue. We're going to have a common factor which is 3 there. Am I right?
Yes, x plus 1. Do you have to do that, sir?
To get to the answer, we have to.
Can I not just say 2, okay, so from the step before you took out the common factor, can I not just say 2 to the power 2x plus 2 over 2?
You can.
But does this taking out the step give you a mark?
Nah, it won't give you a mark.
So can I leave it out?
Yes, you can.
No, I can't, because then it gives you a different answer.
Okay, look at this. It's a bit challenging though. I get it. I get why it's giving you a different answer. Look at this. We can write it the way you did it.
Okay.
Do you see that?
Yes.
However, when we divide this, it means 2x divided by 2 plus 2 divided by 2. That's what it means. Right?
Okay.
And 2x divided by 2, we're going to get x.
Oh, it's not 2x. Okay.
And then 2 divided by 2, we're going to get 1. And then 3x divided by 3, we're going to get x again. And 3 divided by 3, we're going to get 1.
Okay, I see my mistake.
Which is going to be, this must be added, and it's going to be 2 to the power 2x plus 2. And it's going to be 2 to the power 2x plus 2. And the answer will be 1.
Sir, please don't erase it.
Sorry?
Please don't erase it. Okay, I'm done.
You're done.
Yes.
Can I give you something similar to that?
Yes.
And I think we can call it a night. We'll continue tomorrow.
Okay,
So listen, if you're gonna have English with Ram Singh at 11, normally what time do you finish?
It's only an hour, sir.
So let's have our class at 12:30. But let me update you because I will have to go somewhere in the morning. So as soon as I'm back from 12:30, we can have the lesson.
Okay, sir. That's fine.
Let's do this one before we go.
Sir,
Yes.
would the answer be 2 to the power 4x? Or 1 over 2 to the power 4x?
Let me see the step before that.
Where does it start? Here.
Take it up a bit. Up again. Isn't it gonna be minus 2 to the power minus 2? Everything is correct except the last answer.
This one.
Everything else is fine except the final answer.
How did you get minus 2?
Figure it out.
This is minus 2 to the power minus 2.
Minus 2x.
Yeah, got it. Okay. Please check.
Can we do corrections?
Yes. Oh, wait. You're going to get it wrong if I Sir, the final answer is a 2 to the power of minus 2x minus 2. No.
Let's do
It's just 2 to
corrections.
the power
Look at this.
minus 2x. But
Here.
Oh wait, 1 minus 1 is 0. Never mind.
Okay.
I got it.
Look at this. You see, when you get to this part, do you see how this 4 will cancel that 4? And all the brackets.
Yes.
And you will be left with 2 to the power x plus 1. And that 5 will get rid of that 5. And you will be left with 2 to the power x minus 1. All over 2 to the power 4x. And that will cancel that and will be left with 2 to the power 2x over 2 to the power 4x. And we are subtracting, it's going to be 2 to the power 2 minus x. But look at this one. There's a bit of a dilemma that we can work out here. Because we have 2 to the power negative 2x. This can be written in many ways. One of them, you can have this as 2 to the power minus 2 to the power x. Do you see that?
Yes.
Or it can also be written as 2 to the power x to the power minus 2.
Yes.
There are two ways in which that can be written. But
How do you know which way to write it?
Both of these ways is correct. Because if we were to simplify it, that will become 1 over 2 to the power minus 2 all to the power x. Or to the power plus 2 all to the power x. Do you see that?
Oh.
Which will be what? 1 over 4 to the power x. Are you following?
Yes.
Which can be written as 1 to the power x over 4 to the power x. Is it still correct?
Yes.
And this, again, can also be written as 1 over 2x all over 2.
Yes.
And this,
okay.
anything to the power 1 will give us 1, okay?
Yes.
So that can be written as 1 over 4x. And this can also be written as 1 over 4x. So both ways are correct.
Okay.
So basically, if you happen to have 3 to the power minus 2x, there are two ways in which this can be simplified. It's either you have this as 3 to the power 2 over minus x, or 3 to the power x minus 2. So that's correct, because when you multiply the 2, it gives you that. And when you multiply this, it also sends you there. Are you following?
Yes.
So I'm going to give you some exercise that you can use to practice tomorrow until we do this.
Okay. Thank you, sir. Thank you, sir. Sir?
Yes?
Can you please send it on Teams?
Okay, I will.
Thank you. Thank you, sir.
You're
Thank you,
welcome.
sir.
You're welcome.
Good night.
Good night.